Hey everybody, in this video I want to dive into a couple of different best practices for autoscaling. So we're going to see some real code, but we're also going to talk about it from a theoretical perspective because I want you to understand it and see it, but I also want you to just have these ideas from a best practice perspective when you're implementing them in your environment. So the first thing that I want to talk about is horizontal pod autoscaling, okay? Now, what does this mean? Well, it means that you're going to take your environment and go this way, right? You're not growing, you're not adding in from a memory and CPU perspective to what already exists. You're literally expanding. So there are a couple of different options. There's the imperative method, which, from a Kubernetes perspective, probably not the best bet in terms of living on the terminal, but you can use it nonetheless. So there's this autoscale command. You specify the object, in this case it's a deployment. Specify the name of the deployment, the percentage. Now, what this is going to say pretty much is when that CPU for the pod hits 75%, that's when you're going to expand. That's when the autoscaling is going to occur. Okay, and then you're setting up min and max. What does this mean? Well, min means the minimum number of pods that should be running, and the max number of pods that should be running. Now, from a Kubernetes-ish perspective, we're not sitting on the terminal from a imperative perspective. We're doing it all declarative here. This is how we can utilize it with a Kubernetes manifest. So the horizontal pod autoscaler object, same thing pretty much. You're specifying the target, in this case, the object or the kind of deployment, nginx deployment, and then you specify min and max along with the metric. So same thing here. If it hits 75%, add more, okay? Now, the next thing is vertical pod autoscaling, and I've never been a huge fan of vertical pod autoscaling. The reason why is because you're kind of, managing your environment like you would a VM when you do something like this, adding more to it, where Kubernetes is supposed to be expendable. So, pods are supposed to be ephemeral. It's supposed to be, nope, it can go away. Yep, it can be added. No big deal. With this method, you're kind of, thinking about it more from like a VM perspective, like a general perspective when managing pods. But it is an option nonetheless. It is becoming more and more popular with tools like StormForge. It's easier and more maintainable to implement versus doing it like this. Okay. And then the next thing we have here is from a cluster autoscaling perspective. Okay, so we looked at pods, where our application is running. Now we're looking at the overall cluster. So with the cluster, you have cluster autoscaler that comes out of the box. But if you want something that's a little bit more performant, you're going to want to look at Carpenter. Okay, so once Carpenter is installed, essentially you just use this node pool object or kind. You specify the requirements. So these are going to be things like what worker nodes Carpenter can manage. So in this case, for example, we're saying in the instance category, so the A instances and the M instances, Carpenter can manage for us. And this is for on demand. We can also change this to spot as well if we want to. So from a cluster management perspective, this is of course a really solid option. We see it a lot in AWS. Now it's available in preview for AKS. So if you're using one of those environments, this is a great solution. Now, this probably won't come up all that much from a best practice perspective when scaling, but I still put it in this category, and that's when we're specifying limits and requests. So notice here how under my resources, I'm specifying the requests and I'm specifying the limits for my deployment, okay? And again, this isn't auto scaling specific, but it does help with scaling because let's say, you have like a memory leak in your application code or something like that. Well, guess what? If you don't set memory limits and requests, what's going to happen? It's going to keep eating memory, eating memory, eating memory. And then before you know it, everything is scaling out. The cluster is scaling out. The pods are scaling out. Everything is scaling out simply because the application that's running in the container, that's running in the pod, has a bug. So this could actually help you a ton from a scaling perspective. And then last but certainly not least, if you want a tool to be able to help you with this from a third-party perspective, check out StormForge for the resource optimization piece and even the pod optimization piece. Outside of the pod optimization piece, the cost optimization piece, okay? So all of your general auto scaling for your pods, for those resources, you can set up if you want them to be more balanced, more performant, etc. And then it even helps you from a cost perspective. Thank you so much for watching. Really appreciate it. And definitely think about these best practices when you're implementing any type of auto scaling for all Kubernetes environments.